Hello everyone, welcome to my YouTube channel. Myself Samiksha from Sri Venkateshwara College of Engineering. Today I will explain about the principle and construction of DC generator. First, DC generator is an electrical machine. It converts mechanical energy into electrical energy. Motor is also electrical machine. It converts electrical energy into mechanical energy. Both generator and motor actions are reversible. Next, principle of DC generator. The energy conversion in a DC generator based on the principle of production of dynamically induced EMF. Whenever a conductor cuts the magnetic flux, dynamically induced EMF is produced according to the Faraday law of electromagnetic inductions. This EMF causes a current to flow in the conductor. This DC generator converts the mechanical energy into electrical energy. Next, we will discuss about the construction of a DC generator. The DC machine having the following main parts. This is the image of the DC generator. It consists of field system, armature core, armature winding, commutator and brushes. First, field system consists of yoke, pole and pole shoes and field winding. So that yoke it is the outer frame of a DC machine and it is made up of cast iron or steel. It provides the mechanical support to the poles and protects the DC machines from the harmful atmospheric elements like dust and moisture. It offers a path of low reductance to the magnetic flux produced by the poles. This is the picture of yoke. Next, poles and pole shoes. Poles are joined to the yoke with the help of bolts. They carry field windings and pole shoes are fastened to them. Pole shoes serve two purposes. One is the support field coils. They support the field coils and spread out the flux in the air gap uniformly. This is the poles and pole shoes. Next, field winding. Field coils or former wounds and placed on each pole are connected in a series. They are wound in such a way that when energized, they form alternate north and south pole. The materials used are normally copper in a field windings. This is the field winding. Next, armature core. It houses the armature current. It provides a path of a very low reductance to the flux through the armature. It is a cylindrical or drum shaped. It is generally built up of a circular sheet, steel disc or lamination. This is the armature core. Next, armature winding. So this is the armature winding. The slots of the armature core hold insulated conductors that are connected suitably. This is known as armature winding. The armature winding of a DC machine is a closed circuit winding. The conductors being connected to a symmetrical manner forming a closed-shaped circuits. The conductors being connected to the symmetrical manner forming a closed loop or series of a closed loop. Depending upon the armature conductors which are connected to the commutator segments, there are two types of armature windings. One is lap winding and another one is wave winding. This is the armature winding. Next, lap winding. Lap winding. The end of each armature coil is connected to the adjacent segment on the commutator. The number of a pole in the lap winding is equals to the number of parallel paths, means A equals to P. It is suitable for high current and low voltage. It is also type of a armature winding. Next, wave winding. The finishing end of a one armature coil is connected to the starting end of the other armature coil and has only two parallel paths. In wave winding, the number of parallel paths is always equals to 2, means A equals 2. It's suitable for high voltage and low current. This is the wave winding. Next, commutator. It is also a part of a DC generator. A commutator converts the alternating voltage generated in the armature winding into a direct voltage. Means it converts the AC voltage to the DC. This commutator is made up of copper segments insulated from each other. It facilitates the collections of a current from the armature conductors. It is a cylindrical structure and it is built up of a wedge-shaped segment of high conductivity. This is the commutator. Next, bearings. A system uses bearing to provide a smooth movement of the different part of a DC machines. The frictions between the machine spinning and a stationary component is reduced with the help of a bearings. As a result, the system components don't require constant lubrication and will last longer. This is the bearings. And next we move on to the brushes. This is the part of the DC generator. The purpose of brushes is to ensure the electrical connections between rotating commutator and stationary external road circuit. The brushes are made up of carbon and rest on the commutator. They collect the current from the commutators and also they are usually made up of carbon or graphite and in the shape of the rectangular block. Number of brushes from spindle depends upon the magnitude of the current to be collected from the commutator. So this the brushes. Next, conclusions of the construction of a DC generator and principle. Conclusion. A DC generator is a mechanical device that converts the mechanical input to the electrical output and the device is used to generate the electricity. The DC generator has a multiple applications in a worldwide and general usage supply appliances and operating the heavy machines factories. This completes the principle and constructions of a DC generator. Thank you.